So today we're going to talk about inverse trig functions. And first of all, I want to remind you that if you wanted to take the derivative of arc sine of x, that it's 1 over square root 1 minus x squared. And if you want to take the derivative of arc tan of x, that it's 1 over 1 plus x squared. Now, just a reminder, arc sine and arc tan mean the inverse sine and the inverse tangent. And so what's going on these problems is that all of them are going to end up with arc sine or arc tan as long as they're in the correct form. But the problem is you've got to get it in that form. So this first problem, it looks kind of like it could be arc sine. It has a square root and it has a subtract sign, which is important. The problem is that this number right here is not a 1. So what we have to do is we have to make it be a 1. And so what you're going to do is we're going to factor out a 4. Now, when you factor out a 4, since there's not a 4 with the x squared, you're just going to divide by a 4. The dx on top, if you just want to change it to 1, that's fine, but the dx is just sort of there. So then next, what I'm going to do is I'm going to take the square root of 4, because anytime you have the square root of two things multiplied, you can separate it. And so we're going to make it 1/2. I can just take it on the outside. 1 over square root 1 minus x squared over 4, and then our dx is out here if you want to write it. Alright, so we have our 1, we have our square root, we have our minus. Now we need whatever's squared, we need to make it look like it's squared. So I'm going to rewrite it one more time and make it x over 2 squared. Because the square root of 4 is 2, so now it looks like it's in the correct form. Now, to finish solving it, you technically have to do a u substitution, because it's not just an x squared, it's an x over 2 squared. So you're letting u be x over 2, du is 1/2, and nicely we already have the 1/2. I know it's on the outside, but as long as it's there, we're good. And so doing the u substitution, we end up with the same thing that we have up there at the top, the integral of 1 over square root of 1 minus u squared. We know that that is arc sine because the derivative of arc sine is that, so the antiderivative is opposite. So this would be arc sine of u, or arc sine of x over 2 plus c. The problem here is that we have to manipulate the question to make it look like it's supposed to, and that can be sort of difficult. Number 2. Alright, again, it kind of looks like it could be arc sine. There's a square root and there's a minus. The very first thing I want to do is work with that 5. I want it to be a 1 there instead of a 5. So I'm going to rewrite it, and I'm going to factor out, I'm just going to make that dx a 1. I'm going to factor out a 5, and then I'm going to divide the 2/5 by it. Alright, I'm going to come down here. I'm just going to factor out that 1 over square root of 5 because it's really separate from everything else, and you can take it out since it's just a number. Now, it has the 1. I need to make the 2/5 x squared look like something squared. So all I'm going to do is like take the square root of the 2/5 x and then square it. And now, if I rewrote that, if I worked out the square root of 2/5 x and squared, I would end back up with what I started with. Now it looks kind of like an arc sine. So I got to do that u substitution thing again. U is whatever's in parentheses. Which I wrote that wrong. Du is square root of 2/5, which is not in our problem. So I'm going to multiply the inside by square root of 2/5. I'm going to take a square root of 5/2 on the outside, and if I want to bring this 1 over square root of 5 out, I can do that as well. So what that leaves me with is square root of 5/2. Let's make that square root a little bit bigger. Times 1 over square root of 5 times 1 over square root 1 minus u squared. Now it looks like arc sine. We have all that stuff on the outside. These two things will cancel, so I have 1 over square root of 2, arc sine of u, and u is square root of 2/5, which I really should make that square root bigger to make sure that the 2/5 is totally inside, and plus c. Again, the hard part here is the fact that you're using u substitution and you have to change things around a little differently. Alright, this one looks kind of like arctan because it has the plus and no square root. The process is still very similar. I need to work with that 16 and I need to make it be a 1. So I'm going to factor out a 16, which means I'm left with 1 plus x squared over 16 dx. So I'm going to separate this and just make it 1 over 16 and then 1 over all that other stuff. I'm going to go ahead and make that be something squared. So take the square root of each part. The stuff in the middle, that looks kind of like arctan. Obviously that's going to be an x over 4. That's going to be what it's going to be the arctan of. But I sort of need to do that u substitution. If you can do it without doing the u substitution, if you can sort of see it, that is perfectly fine. We'll have to put in a 1/4 and take out a 4. And then 1 over 16 will go outside with the 4. So I have 4 over 16 integral, 1 over 1 plus u squared, which is 1/4. And I know that that's arctan of u, or arctan of x over 4. All right. This one looks like it could be an arctan kind of problem, but I have a 2x on the top. So this problem is just a plain old u substitution problem. I wanted to throw in there to let you know, just because it looks like it might be arctan doesn't mean that it has to be. We can let u be 4 plus 2x squared. du is 2x. Everything's there like we want it to be. Find the antiderivative, ln of u, which is 4 plus 2x squared. So this problem doesn't involve arcsine or arctan at all. And so be mindful that some of these problems don't have to be solved by arcsine or arctan. Alright, here's another one that looks like it could be arctan because of the plus. The x is kind of confusing. Well, I'm going to show you that it is arctan and that it'll work out, and I'm going to show you what to do with that x. But let's just pretend like the x isn't there for a moment. Let's go ahead and factor out that 9 to make that be a 1 on the top. On the bottom, sorry. And then you divide by that 9 when you factor it out. Alright, next, if you want to take the 1/9 on the outside, that's okay. Or we can just sort of keep working with it. The x could go on in front of, or on top of the 9 if you want it to. It really doesn't matter. I'll go ahead and put it on there just so it looks kind of the same. I need it to be something squared. That's x to the 4th over 9. So that would be the same as x squared over 3. Now we're getting to the correct form. We just have to figure out how to deal with that x squared over 3. We do that u substitution again. Here's where that x is important. You see that x there? Well, that's nice that that x is already there because you can't ever add in an x. So I do need to multiply by 2/3, which means I need a 3/2 on the outside. This 9 on the bottom is still there. That's not part of our problem. We're going to take it out with the 3/2. So then we have 1/6 arctan of u, or arctan of x squared over 3. Alright, this problem here. It looks complicated because it has an x plus 2 here, but it's already in the form of arctan. It's 1/1 plus something squared. The something, if you take the derivative of x plus 2, you get 1, so you don't have to do anything with u substitution. We can automatically say that this is arctan of x plus 2. Alright, this one, similar to the last one, except unfortunately it doesn't have 1 plus something squared. So, again, I have to factor out that 2. Alright, and I need to rewrite it to make it 1/1 plus something squared. Just take the square root of the 2. Alright, time for u substitution since u is not just 1 anymore. du will be 1/square root of 2. Multiply by 1/square root of 2, multiply by square root of 2 on the outside. That gives us square root of 2 over 2, because that 1/2 is out there with the square root, times the integral of 1/1 plus u squared. Now we're to arctan where we thought we should be. That square root of 2 over 2 should be there. U is x minus 1/square root of 2. And there we go. Alright, the last 3 problems I want to show you is something new that's on the AP test. And it's the similar kind of problem as 6 and 8, or 6 and 7, except you have to complete the square to make it look like those other problems. So, here's what you do. You separate what's going to happen here. We're going to add something in here. What we're wanting to happen is we're wanting to be able to factor this into something squared. So what you do is you take half of the middle term, which is 1, square the 1. That's 1. That means we added 1 to make that work. Well, if we add 1, okay, so I'm going to re-say what I was saying here. Basically, you find half of the 2, which is 1. You square the 1, that's 1. That's what you added. And so what you have to do is you have to do the opposite outside here. So since I added 1 here, I have to subtract 1 there. Like I have to do the opposite. And so what happens is I get plus 1, because 2 minus 1 is 1. So what happened, let me just show you kind of out to the side again. You take half of that, which is 1. 1 squared is 1, so I've added a 1. This 2 is just separate, but I added 1, so I have to subtract 1. And that's completing the square, but I just know it's been a long time since you've done completing the square. Alright, we're going to do several more like it, so I think you'll be able to pick up on it. Now, this problem now looks like an arctan problem. The 1 and the x minus 1 squared are switched, but it's the same thing. If you want to rewrite it as 1 over 1 plus x minus 1 squared like that, you're welcome to. Now it looks like 1 plus something squared. So the answer here is arctangent of x minus 1. The derivative of x minus 1 is 1, so I don't have to use substitution or divide. Alright, number 9. Very, very similar kind of problem. So I'm going to add something here, which means I have to subtract something here. And here's how I figure it out. I'm going to take half of the 4, which is 2. 2 squared is 4, so 4 is what I'm adding. That means 4 is also what I'm subtracting. So here, this is the x minus 2 squared. This, 8 minus 4, is 4. Now, it kind of looks like an arctan problem. If you want to rewrite it, you can. And now, this is where we have to make that 4 look like a 1. So I factor out a 4. And then here's where I need to make this part of it be something squared. Alright, getting closer. That's what I'm going to let u be. So I have to put in the 1/2, take out a 2, and that 1/4 can come out there with the 2. So I end up with 1/2 integral 1 over 1 plus u squared, which is 1/2 arctan of u, or x minus 2 over 2. One last one, probably blowing your minds, but do the best you can with it. We'll talk about it tomorrow. So we're still completing the square. We're going to add something on both places. Half of 6 is 3. 3 squared is 9. So it's a plus 9 and a minus 9. That means this is a plus 3. If you want to rewrite it, you can. Factor out a 3. Use substitution again on this part right here. The cool thing is that 1/3's in there, so I don't have to add anything. So this just gives you 1 over 1 plus u squared, which is arctan of x, or u, and u is x minus 3 over 3. Basically, when we're doing u substitution, what you get for du, you're just dividing the arctan of whatever it is divided by that. Just like whenever we did the table problems with integration by parts and how you divided by the derivative every time, that's basically what you're doing here. And if that makes sense, you really don't have to do u substitution.